Hello, and welcome to Algeomula's Prep Academy. Today's lesson is about finding volumes using the shell method revolved about a line. As a quick reminder, here is the formula for the surface area of a cylinder. We derived the shell method formula using this equation. Here is the given shell method formula for revolving about the x-axis, where b and a represent the top and bottom bounds, r of x represents the radius of the cylinder, and h of x represents the height of the cylinder. Here is the given shell method formula for revolving about the y-axis, where d and c represent the top and bottom bounds, r of y represents the radius of the cylinder, and h of y represents the height of the cylinder. For the first problem, we will be finding the volume of the region bounded by y equals negative x minus 3 squared plus 4, located in the first quadrant revolved about x equals 4. We find h of x from subtracting the top function and the bottom function, and r of x is found by subtracting x equals 4 and x. Here is a visualization of one of the sections of the graph revolved about the line x equals 4. It creates a cylinder. First, we need to solve for the upper and lower bounds. We can do that by having the two given equations equal each other and solve for x. Negative x minus 3 squared plus 4 equals x minus 1. X will equal two different numbers, 1 and 4. These numbers will be our lower and upper bounds respectively. Now let's set up our equation using the x-axis shell method formula. We can substitute bound b with 4 and a with 1. R of x can be substituted with 4 minus x, and h of x can be substituted with negative x minus 3 squared plus 4 minus x minus 1. After taking the integral and evaluating the bounds, we can get a final answer of 42.412. Now let's take a look at another example. For the second problem, we will be finding the volume of the region bounded by y equals negative x cubed over 5 plus 7, x equals 0, and x equals 3 revolved about y equals 7. Before we solve for bounds, we need to find the equation of x in terms of y. We can do that by solving for x through isolation. We will get an equation of x equals the cube root of negative 5y plus 35. From there, we can get h of y by subtracting the right and left functions, and we get r of y by subtracting y equals 7 and y. Here is a visualization of one of the sections of the graph revolved about the line y equals 7. It creates a cylinder. To solve for the upper and lower bounds, we need to solve for y using the given equation of the cube root of negative 5y plus 35 equals 3. We will get a y value of 1.6. Our upper and lower bounds are 7 and 1.6 respectively. Now let's set up our equation using the y-axis shell method formula. We can substitute bound d with 7 and bound c with 1.6. R of y can be substituted with 7 minus y, and h of y can be substituted with 3 minus the cube root of negative 5y plus 35. After taking the integral and evaluating the bounds, we will get a final answer of 39.261. This example is similar to the previous example. In this example, we will be finding the volume of the region bounded by y equals negative x cubed over 5 plus 7, x equals 0, x equals 3, revolved about y equals negative 2. h of y is still the same function, and we find r of y by subtracting y and y equals negative 2, getting an r of y plus 2. Here is a visualization of one of the sections of the graph revolved about the line y equals negative 2. It creates a cylinder. Now let's set up our equation using the y-axis shell method formula. We will be using the same bounds as the previous equation. We can substitute d with 7 and c with 1.6. R of y can be substituted with y plus 2, and h of y can be substituted with 3 minus the cube root of negative 5y plus 35. After taking the integral and evaluating the bounds, we will get a final answer of 189.761. Thank you for watching Algae Prep Academy.